Greetings from Sarala. I'm a retired head Department of Physics and Electronics from St. Anne's College for Women. Here, I am giving you a few concepts from the Board of Intermediate Education Physics lessons. Basically, this is my channel. I've dedicated it to those enthusiastic learnings who would like to listen a few concepts of physics, try to understand them, apply them, and then enjoy learning physics as a passion, not for a rote learning. So here we go. I will be posting few of my videos in my channel. You can please do watch, comment, and let me know how I can help you out. All the very best to all my dear children. Let me start with the first, let's see. Today, we are going to introduce the topic on wave. Wave is something, which is a disturbance that is created in a medium and energy travels through the medium. You can see it is a wavy pattern. There is a movement of energy and that is known as propagation. Okay. So there are some waves which require some medium and there are some other waves which do not require any medium for its propagation. So before we go into that, let us try to understand what are the key features of the waves. Waves are basically vibrations. They can be pressure change, they can be field vibration, and so on and so forth. And we have some attributes of the wave, which are known as wavelength, frequency, amplitude, and speed. Let us try to understand them. What these are. The wavelength is a distance between two consecutive points. You can represent a wave like this. You can see these are the crests. It's in the form of a sinusoidal wave or it can be a cosine wave. The distance between two crests or between two troughs is referred to as one wavelength. And you can see that this is a pattern which is getting repeated. So this pattern is referred to as one cycle. And the time taken to complete one cycle is time period. The number of oscillations in one cycle is your frequency. So in 1 second, if there is only one cycle, then it is frequency is 1 hertz. Hertz is a unit of frequency. If it completes 2 cycles of this type, then the frequency is 2 times. 3, 3, 4 times 4, and so on. Okay. Now these waves that we are talking about are classified under 2 categories. One is mechanical wave, the other one is electromagnetic wave. Mechanical waves are the ones which require medium for its propagation. Electromagnetic waves do not require. They travel through the space. All which is pervasive in the space are referred to your electromagnetic waves. Your radio waves, all your TV signals, satellite signals are all electromagnetic waves. Microwaves, infrared waves, all these are under this category. In the mechanical wave category, you have 2 types, the longitudinal waves and the transverse waves. Longitudinal waves are sound waves, the other ones are waves. So let us now try to concentrate on what a transverse wave is and what a longitudinal wave is. So you can see it's in the form of a rope made to oscillate, right? So if the wave is moving in this direction, let us say if it is x-axis, the particles of the wave, which are constituents of the wave, move up and down, then it is known as transverse wave. If it is in the same direction, then it is longitudinal. So more clearly, you can see this animation here. So particles are moving, wave is also moving in the same direction. At some points, they come closer, they are called compressions. At some points, they are wider, they are called rarefactions. This is another way of representing the same. As you can see, the closed spaces, when they come closer, it is compressed. When they move out, it is stretched, it is rarefaction. This is yet another visualization. Propagation is, as you can see, along the y-axis. Here the propagation is along the x-axis. The speed is calculated by using the formula V is equal to F lambda. V is the speed F is the frequency, lambda is the wavelength. And it can also be calculated in a string by a formula known as square root of T by mu, where T is the tension and mu the linear density, that is mass per unit length. This is all the electromagnetic spectrum. You have different waves. These onto the left, the ultraviolet is your visible radiation. Onto the left, you have these waves, radio waves, microwaves. Onto the right, you have X-rays, gamma rays, and so on. Concentric circles, waves, and sound waves travel through air as vibrations, light waves, and so on. Now, what a wave is, what you've understood, you know what a longitudinal wave is. Now let us see what is a standing wave. You require two waves moving in the opposite direction, having same phase, same amplitude, and same frequency. And when they are propagating in the same medium, there are points where they interfere constructively, and some points they interfere destructively. So the points where they constructively interfere are known as the points of nodes, where I'll show you. This is wave 1, this is wave 2. So some points they're closer coming to the and some are wide apart. So the points where there is no displacement are referred to as nodes. The points where there is maximum displacement are referred to as antinodes. That is what is explained here. And the distance between a node and an antinode is lambda by 2. The distance between any two nodes is lambda. Mathematically, this is how you represent. These are the physical examples. So if there is one loop, it is first harmonic. If there are two loops, it is second harmonic, three loops, and so on. So positions of nodes and antinodes are calculated like this.